word of the day: when opportunity and preparation meets, that's where the magic happens. Let's start with functions. So that's the general formula for grade 11, 12 functions. So let's look at the figure that's given to us. We can write down the coordinates that we do have, and so that's the x-intercepts and then the one y-intercept. So we can use these points to actually determine the equation of the formula of the function. Right. So this is a positive graph, and we'll do some more analyzing later. So let's determine the equation of the function. Let's write down the points that we do have. That's two x-intercepts cutting the x-axis and the one y-intercept. Right. So there's a formula that we can use to find the equation. It's y equals to a open bracket x minus x1, the first x-intercept, and then x minus x2, which is the second x-intercept. That's x1, that's x2, we can label it as such. And then we substitute. Now it's very important to substitute with brackets so that you don't get the wrong signs in the brackets. Right. So it's going to be open bracket x minus open bracket 3 close bracket. This is just to be safe. So a x plus 1 and then x minus 3. Can you see the values in the brackets is way different to the intercept itself? It's the opposite actually. Right, so then we substitute the y-intercept to get the value of a. So now we can only have one variable. So it's 0 plus 1 and then 0 minus 1 minus 3. And here we know that 1 times 3 is obviously going to be negative 3. And then we divided by negative 3 both sides. And then a is equal to 1. So now we substitute y equals to, in the place of a we put 1. So it's going to be 1 open bracket x plus 1 and then x minus 3. Now remember that we want to get the formula that we showed earlier on top. So now we can multiply out the brackets, and that's going to give me minus 3x plus 1x minus 3. And then y is equal to x squared minus 2x minus 3. And there we go. And so there we have our trinomial in standard form. Okay, next question is determine the turning point. Now these are all typical exam questions. We have a formula that we can use is minus b over 2a. And so now you need to know where these letters occur. So now a is in front, the coefficient of the x squared, and b is the coefficient of the x to the power of 1, and c is the constant. So we substitute minus 2 over 2 times 1, and a is 1. There we go. And so x is therefore equal to 1. And then we substitute the 1 that we got into the original equation. So it's going to be open bracket 1 to the power of 2 minus 2 bracket 1 minus 3, and therefore y is equal to, I put this part in your calculator, and then you easily get that y is equal to negative 4. There you go. And so our coordinates that we have for the turning point is going to be 1 and negative 4. Let's test it and check and see if it makes sense to the graph. And there we go. And so you can see there it's 1 and negative 4. Okay. The axis of symmetry, where a line cuts the graph into two equal halves. And so we only simply use the turning point formula, but only the first part determining the x. So it's going to be minus b over 2a, and then we substitute again. We saw earlier that b is negative 2, so it's going to be minus 2 over 2 times 1. And so now x is equal to 1, and therefore let's check. If you draw a vertical line here by 1, cutting the x-axis at 1, does it cut the graph into two equal halves? Yes, it does. And there we go. That's our axis of symmetry. Then the domain and range. And this is my favorite part. Okay, so domain refers to the x-axis. And now we check how far on the positive side does the graph go until positive infinity. And on the left hand side, how far does it go? Negative infinity. And so here you can see that x is then an element of real numbers. Now the range is quite different here, slightly different. Now the range asks a question in such a way that you can see where the graph starts. So where does it start and where does it go to? It goes up until positive infinity, but it starts at -4. So we're going to write down y and -4. Now you're going to ask yourself, is it greater or less than? And we can conclude it's greater and equal to -4. There we go. That's our domain and range. Now we get to grade 12 level, inverse. Now I'm not going to do the calculation. I'm just going to show you how we can simply get the inverse from having the coordinates. Right, so let me write down the coordinates of the original function. F of x, so that's the original one. And so we note it like that. And so let's write down all the intercepts. It's -1 and 0. Then 3 and 0. And then 0 and -3. That's a y-intercept. And so now if we want the inverse, which is x to the power of 1, x to the power of -1. So now we swap the x and the y values. So instead of -1 and 0, I have 0 and -1. Right? Can you see that it's swapped? I swap that around, and then 0 and 3. Which means these are now the y-intercepts. And the last one is going to be an x-intercept. So let's plot it and see what it would look like. Now this will be a rough sketch on my end, just to show you if we plotted what it would look like. Okay, so let's plot it, and there I connect the 3 coordinate points. There we go. Make arrows on either side showing it continues. Now my question to you, grade 12s, is this a function? The one I drew now in blue. Is it a function? Yes or no? No, it's not, because a vertical line test will cut it twice. Now, to make this a function, we need to add a restriction. Right, so now we're going to say y is greater than 0, which means from 0 on the y-axis upwards. And therefore, we have to remove some things. So we're going to remove the bottom part of the function. There we go. And so that is my function. Is this a function now that is restricted? What do you guys say? Would it pass the vertical line test? Yes, it will. Right. And so there we have it, people. Functions in a nutshell.